Here is a question that sounds like a dare. What actually happens inside a microwave when you put metal in it? You have probably heard the warning 1,000 times. Keep metal out of the microwave, but nobody ever tells you the real reason why. Today we are going to fix that, and by the end you will understand something that even most adults cannot explain properly. Stick around, because the answer involves invisible electric fields, tiny lightning bolts, and the same physics that makes power lines hum. First, let us talk about what a microwave oven actually does. Inside every microwave is a device called a magnetron. A magnetron is basically a tube that turns electricity into microwaves, which are a form of electromagnetic radiation sitting between radio waves and infrared light on the spectrum. The magnetron in a typical home microwave pumps out about 700 to 1200 watts of microwave energy at a very specific frequency, 2.45 gigahertz. That means the electric field inside the oven is oscillating, flipping back and forth, about 2.45 billion times every single second. Water molecules in your food are electric dipoles, meaning one end is slightly positive and the other is slightly negative. When that field flips billions of times a second, those water molecules try to spin and align with it, and all that spinning creates friction, and friction creates heat. That is how your soup gets hot. Simple enough. Now drop a metal fork in there. Everything changes immediately. Metals are conductors. That means they are absolutely packed with electrons that are free to move around. When the microwave's oscillating electric field hits the metal, those free electrons do not gently spin like water molecules. They sprint. The field shoves them hard to one end of the fork, then reverses and shoves them back the other way, 2.45 billion times per second. This creates a surging electric current inside the metal, and that current builds up charge especially fast at sharp points and thin edges, like the tips of fork tines. Here is where it gets spectacular. When enough charge piles up at a sharp point, the electric field right at that tip becomes absolutely enormous, far stronger than the surrounding air can resist. Air normally acts as an insulator, but every gas has a breakdown voltage, a point where the electric field is so intense that it rips electrons right off the air molecules and turns the air into a plasma. That plasma is electrically conductive, which means current can suddenly arc right through it. You see that arc as a bright, crackling spark. This is called dielectric breakdown, and it is the exact same process that makes lightning shoot between a storm cloud and the ground. Your microwave is running a tiny lightning storm because of free electrons in metal and a field strong enough to ionize air. So why do sharp edges make it worse? Think of it this way. If you squeeze the same amount of water through a wide pipe and then through a narrow straw, the pressure at the straw is way higher. Charge works the same way. The same amount of charge squeezed onto a tiny sharp point creates an enormously concentrated electric field right there at the tip. Fork tines, crumpled aluminum foil edges, even the rim of a gold-painted plate all act as lightning rods inside your oven. Smooth, rounded metal objects with no sharp points or edges, like a smooth metal spoon, can sometimes sit in a microwave with much less sparking, though it is never truly safe, and the oven's manufacturer will always tell you not to try it. There is a second problem beyond sparking. When metal causes arcing inside a microwave, the plasma it creates can reflect microwaves in chaotic, unpredictable directions. Some of that energy gets bounced back toward the magnetron itself. The magnetron was designed to send microwaves outward, not to absorb them. Reflecting energy back into it can overheat it and break it, sometimes permanently. That is how people ruin ovens in seconds. Now here is something cool that flips the whole story around. Engineers and scientists actually use carefully controlled microwave heating of metal all the time. Microwave-assisted sintering, a process where metal powders are fused together using microwave energy in specially designed industrial chambers, is a real and growing field of manufacturing research documented by institutions including the Department of Energy and universities such as Penn State. The physics is the same, but the geometry and power levels are engineered, so arcing is controlled or prevented. Knowing why metal sparks in a home microwave is the first step toward understanding how to use that same energy safely in a professional setting. So let us pull the whole story together. A microwave creates an electric field oscillating billions of times per second. Metal is full of free electrons that respond to that field with massive rushing currents. Sharp edges concentrate those currents into tiny points where the electric field becomes so strong it breaks down the air itself into plasma. That plasma glows and crackles as a visible arc, which is essentially miniature lightning. And the reflected energy from all that chaos can destroy the magnetron. That is the full, real, physics-based answer to why metal sparks in a microwave oven. Next time someone tells you to keep metal out of the microwave, you can tell them exactly what is happening. Dielectric breakdown, ionized plasma, and the breakdown voltage of air. That is not just a rule. That is a lightning storm in a box, explained by the same electromagnetic principles James Clerk Maxwell wrote down in the 1860s. Pretty good reason to use a glass bowl.